In this video, we are going to learn about equivalent fractions. To understand what we mean by equivalent fractions, first of all, let us consider three rectangles, 1, 2, and 3. Now, let us divide the first rectangle into 6 equal parts. Let us divide the second rectangle into 4 equal parts. And let us divide the third rectangle into 2 equal parts. Now, let us shade these 3 parts for the first rectangle, and for the second rectangle, let's shade these 2 parts, and for the third rectangle, let us shade this part. Now, we can see that we have shaded the same proportion of each of the 3 rectangles. Now, in the first rectangle, we have a total of 6 parts, so 1, 2, 3, 4, 5, and 6. And out of them, 3 are shaded. So what fraction does that represent? It represents the fraction 3 divided by 6. If we have a look at the second rectangle, we have 1, 2, 3, 4 parts. And out of those 4 parts, 2 are shaded. So what fraction does that represent? It represents 2 divided by 4. And if we have a look at the last rectangle, we can see that there are 2 parts, and out of them just 1 is shaded. So what fraction does that represent? It represents 1 divided by 2. But we can see that the same proportion of all of the rectangles has been shaded. What does that mean? That just means that all of these fractions are the same. So 3 divided by 6 is equal to 2 divided by 4 is equal to 1 divided by 2. We call fractions like these equivalent fractions. That is, equivalent fractions are fractions which have the same value but have different numerators and denominators. Now, how can we find equivalent fractions? We can do that in 2 ways. The first way is to multiply both the numerator and denominator by the same non-zero number. And the second way is to divide both the numerator and denominator by the same non-zero number. For example, let us consider the fraction 4 over 8. Now let us multiply both the numerator and denominator by 2. So we have 4 times 2 and 8 times 2. Now 4 times 2 is 8. 8 times 2 is 16. So we have 8 over 16. Now let us once again consider 4 over 8. And this time let us multiply both the numerator and denominator by 3. So what do we end up with? We have 4 times 3, that is 12, and 8 times 3, that is 24. So we have equivalent fractions. That is 4 over 8, 8 over 16, and 12 over 24. All of these fractions are equivalent fractions. Now, once again, let us consider 4 over 8, and let us divide both the numerator and denominator by the same non-zero number. So let us divide both of these by 2. Then what do we end up with? We have 4 divided by 2, that is 2, and 8 divided by 2, that is 4. Now if we once again consider 4 over 8, and this time we divide the numerator and denominator by the number 4. Then what do we get? We have 4 divided by 4, that is 1, and 8 divided by 4 is 2. So what do we end up with? We see that 4 over 8, 2 over 4, and 1 over 2. These are equivalent fractions. And they're also equivalent fractions to 8 over 16 and 12 over 24. All of these fractions have the same value, but the numerators and denominators are different, so all of them are equivalent fractions. Now, one thing we need to remember is that the number we multiply or divide the numerator and denominator by must be non-zero. It has to be non-zero. We cannot multiply both the numerator and denominator by 0. We cannot divide by 0 either. We need to select some non-zero number, and in that way we can obtain equivalent fractions. Now let us have a look at a few practice problems. Now first of all, we have been given the fraction 4 over 20. Let us determine some equivalent fractions. So we have 4 over 20. First of all, we can obtain an equivalent fraction by multiplying the numerator and the denominator by the same non-zero number. Let's multiply the numerator and denominator by the number 2. So we end up with 4 times 2, that's 8, and 20 times 2, that's 40. Now, next, we have 4 over 20. This time, let us multiply the numerator and denominator by the number 5. Now, if we do that, what do we get? We have 4 times 5, that's 20, and 20 times 5, that's 100. Now, let us determine a few equivalent fractions using the second method, that is, dividing both the numerator and denominator by the same number. So we have 4 over 20. Let us divide both the numerator and denominator by 2. Then what do we get? We have 4 divided by 2, that is 2, and 20 divided by 2 is 10. Once again, let us consider 4 over 20, and this time let us divide both the numerator and the denominator by 4. Then what do we get? We have 4 divided by 4, that is 1, and 20 divided by 4, that is 5. So we have found some equivalent fractions. That is 4 over 20, 8 over 40, 20 over 100, 2 over 10, and 1 over 5. All of these are equivalent fractions. Now let us consider the next problem. Here we have 15 over 45, and this is equal to something over 9. Now, what is that something? So what do we have? We have 15 over 45, and this is going to be equal to something over 9. So first of all, note that we have 45 in the denominator here and 9 in the denominator here. Now, how can we go from 45 to 9? To do that, what we need to do is divide 45 by 5. That is, 45 divided by 5 is 9. And we want an equivalent fraction, so we need to divide the numerator by that same number. So we have 15 divided by 5. And 15 divided by 5, that is equal to 3. So what do we end up with? We have that 15 over 45 is equal to 3 over 9. Now, let us consider our next problem. We have 7 over 10 is equal to 21 over something. Now, what is that something? We have 7 over 10. This is equal to 21 over something. Now, consider the numerators. We have 7 over here and 21 over here. Now, how can we get from 7 to 21? To do that, what we need to do is multiply 7 by 3. And we want an equivalent fraction, so we need to multiply the denominator by that same number. So we have 10 times 3. And 10 times 3 is equal to 30. So what do we end up with? We have that 7 over 10 is equal to 21 over 30. So 21 over 30 is our required equivalent fraction. Thanks for watching this video. I hope you enjoyed it. Don't forget to comment, like, and subscribe. See you next time.